right, guys. Can I get a thumbs up at home that you can hear me and see the board okay? Everybody's good? Okay, well, happy Monday. We have 4 people right now in class. I am very excited. We are going to continue in section 5.6. The notes I gave you guys on Friday were like 3 pages long. The last page we did not get to. I'm actually still going to hold off on that. I want to do a couple more log equations, maybe some more difficult or weirder looking ones, if that's even a scenario, before we get to the exponentials. So here we go. Doing our log equations. I just want to show you guys a couple of methods that you may see in calculus that are used, just so you guys are aware of them. When you are dealing with log equations, sometimes when they are a little bit more difficult, or maybe a little bit different looking, if you will, there's something called U substitution. You want to look for a reoccurring part of the problem that can be taken out, and a U can be substituted in its place. And then sometimes, a lot of the times, it may turn into like a nice factoring type problem, now that it looks a little bit more normal and not so weird, okay? And then there's also change of base. Logs in different bases throughout the problem. So if you have a log base 4 and a log base 2, clearly all these properties only work for same base logarithms. Well, now that we have the change of base formula, now we can do that. We can get everything in the same base. So sometimes you might have to rewrite the problem in a different base. All right, so let's look at example 1. And then always check for extraneous solutions. You cannot take the log of a negative number or 0. All right, let me move mine up, give myself a little bit more space. All right, so guys, let's look at this one. Our job is to solve this equation for x. So now it says log base 2 of x quantity squared. So guys, this is different. This 2, this exponent, it's not inside the log. It's not part of what you're taking the log of. So you can't use the property to bring it down in front. It's not what it's saying. This is literally log base 2 of x times itself 2 times, log base 2 of x. And then minus 3 times log base 2 of x equals 10. So you see how you have this reoccurring log base 2 of x? I have it here and I have it here. So let's try a U substitution. Let's let U equal log base 2 of x, this reoccurring piece of the problem. So now everywhere you see a log base 2 of x in the problem, substitute a U. So instead of log base 2 of x squared, that's just going to be U squared because it's log base 2 of x. And then minus 3 times, not log base 2 of x, we're letting that be U. And then it equals 10. So now when you see this problem as a U substitution, guys, you're solving a quadratic equation. That's a quadratic equation. Let's hope it factors. Let's get everything on one side and see if we can factor it. So it'll be U squared minus 3U minus 10 equals 0. Well, if I try to factor it, I know a U and a U will get me U squared. Numbers that multiply to negative 10 that then add up to negative 3, that's a negative 5 and a positive 2. I should have a better marker. Wait, there she is maybe. All right. All right, so now we solve set each factor equal to 0, and you get U equals 5 when you set this factor equal to 0, and you get U equals negative 2. Okay. Now that you have finally solved the problem, now you have to go back. It's not really U that we were solving for, it was x. So now we have to put log base 2 of x back into the problem for U. So now it's not U that equals 5, it's log base 2 of x that equals 5. But guys, we can solve this. This is a little tiny log equation. Either use your log loop that says 2 to that power equals that answer, or I could exponentiate or base both sides to a base of 2. And now they cancel, and x is equal to 2 to the 5th power. And 2 to the 5th power, guys, is 32. So now I know x equals 32. And then I come over here, it's not U that equals negative 2, it's log base 2 of x that equals negative 2. Now you got to take the U back out. All right, so now 2 things. You can rewrite this in exponential form using your log loop that would say 2 to that power equals that answer, or I could just base both sides to a base of 2. And then it'll be x equals 2 to the negative 2 power, which is 1 over 2 squared which is 1/4. And now 1/4 is your second answer. Okay, and now we have to check for extraneous. You want to make sure that if x is 32 or if x is 1/4, does any of that result in you now taking the log of a negative number or 0? So go back to the original. If x is 32, I'd be taking log base 2 of x, or 32, it's fine. I'd be taking log base 2 of 32. 32 is fine. 1/4, I'd be taking log base 2 of 1/4, log base 2 of 1/4. Both of them are fine. None of it is you taking the log of a negative number or 0. So you keep both answers. How'd that feel, okay? Everybody good? All right, so again, sometimes what may look like a weird looking problem, when you put a u in its place, it's like, oh my God, it's a factoring problem. It's a u substitution. It's not that bad, okay? It's meant to kind of calm the problem down a little bit. All right, let's try another one. Everybody okay? Yes? Okay. All right, now this one, we're going to put your factoring skills to the test a little bit. All right, look here. We have the natural log of x minus 3 times the square root of the natural log of x. So again, guys, this is weird in the sense that normally we'd be taking the square root of x, right? The natural log isn't usually part of underneath that square root. Now it is, so that's different, right? And then plus 2. So I have this reoccurring natural log of x. Let's take that out, let's put a u in its place. All right, so every time you see the natural log of x, put a u there. So this will be u minus 3 times the square root of u, and then plus 2 equals 0. Now again, you could sit there and say, I don't know, Hardy, it still don't look that pretty. It really doesn't, but it's not that bad. So now I'm going to get rid of that square root, right? Logs, exponentials. Let's look at exponents, not square roots. So now I'm going to rewrite this as u minus 3 to the 3 times u to the not square root, but that's the square root to the first power, 1/2. Power over a root. Plus 2 equals 0. Okay. So guys, now think about it. If this was u squared minus 3u plus 2, would that factor? Yeah, that would be what? U minus 2 and u minus 1, right? It would factor if it was u squared. It's not. However, it does factor. Think about it. This is u to the first power. Does anybody know what I could put here and here that would multiply to u to the first, but then still allow me to get u's to the 1/2 in the middle? U to the 1/2. It's u to the 1/2 and u to the 1/2, right? Think about it. Because if I multiply them, what do you do with exponents? You add them. So 1/2 plus 1/2 is 1. And then these are still going to allow your rainbow pieces to get to the u to 1/2 in the middle. So it does factor. And now what's going to multiply to that positive 2 and then add up to those negative 3 u's to the 1/2? A negative 2 and a negative 1. Just like this, except I don't need u's, I need u's to the 1/2. Does that make sense? Is everybody okay? Excellent. All right, now we solve it. So now I'm going to get what? U to the 1/2 equals 2 when I set this factor equal to 0. And I'm going to get u to the 1/2 equals 1 when I set that factor equal to 0. Well, let's get u by itself. Let's square both sides. You can go back to a square root. You'd still end up squaring both sides to do that. So now they cancel. You get u equals 4. They cancel. You get u equals 1. But remember, now that you finally have solved for u, it's not really u that we were ever solving for. U represents the natural log of x. Now you got to put the natural log of x back in. All right, so let me come up here. So if u equals 4 and u equals 1, well, really, that's the natural log of x equals 4. All right, and then 2 things. If you want to solve this, it's written as a logarithm with base e. Use your log loop to rewrite it in exponential form. E to that power equals that answer, or you could base both sides to a base of e, and you get x equals e to the 4th. Now remember, e is not a variable. E is a number. It's the limit of 1 plus 1 over n to the power of n which is approximately 2.718. So that's a number, guys. And then u equals 1, we're going to let that be the natural log of x that equals 1. And then whatever you want to do, it's a base e logarithm. Rewrite it in exponential form using your log loop. E to that power equals that answer, or I could base both sides to a base of e. And x equals e to the first, which is e. So our two exact answers, not rounded, are e to the fourth and e. Now let's just make sure that both of them are perfectly acceptable answers. Just give me 1 second. Okay. Oh. Okay. So guys, this is about 53, a little bit higher. If that's 53, I'd be taking the natural log of 53, the natural log of 53. I am not taking the natural log of a negative number or 0, so he's a keeper. E is about 2.7, right? So that would be a positive number, and that would be a positive number. I would not be taking the log of a negative number or 0, so we keep them both. All right, how do we feel? Everybody good? Awesome. All right, so that's how we can use a U substitution to, again, make a problem look maybe a little bit more normal and a little bit easier to factor. All right, let's try another kind. Now with these ones, I'm pretty sure on your homework, they give you the hint. They tell you what they want you to do to solve these ones. All right, so guys, we have log base 2 of x plus 16 minus log base 4 of x. So guys, we have a base 2 log and a base 4 log. So don't jump the gun and be like, oh, I'm going to put these two logs back together using division since they're separated by subtraction. No, that's a base 2 log, that's a base 4 log. Can't use that property on different base logs. All right, and it equals 3. So they give you a hint. Use the change of base formula to rewrite log base 4 as log base 2. So we're going to rewrite this log base 4 as a log base 2, because then we'll have everything in the same base, and now maybe there are properties that we're going to be able to use. All right, so log base 2 of x plus 16 is going to stay, minus. All right, we're changing this log base 4 to a log base 2. So your change of base formula says this becomes log better base, which is 2, of who you were originally taking the log of, which was x, over log better base 2 of your old base 4. Okay? And then that equals 3. So guys, it's not the prettiest problem, but now every log is in the same base. Well guys, normally they're going to throw a bone at you when they give you these problems. Does anybody recognize something that we already know the answer to? Anybody know what log base 2 of 4 really is? 2 to what power is 4? It's 2. We know the answer to that log, so take it out. We don't need it. We don't need log base 2 of 4. We know the answer to that log. So now it's log base 2 of x plus 16 minus log base 2 of x over 2 equals 3. Well, guys, just like any normal algebraic equation, if I'm dealing with a fraction and I don't want to, let's times everything by that least common multiple, that least common denominator, and then we can get rid of it. So since the only denominator is 2, I'm going to times this entire problem by 2, and I'm going to get rid of that. All right, so this is going to become 2 times log base 2 of x plus 16 minus, when I distribute the 2 here, this 2 and this 2 will cancel and just leave you with log base 2 of x. Equals 2 times 3 is 6. Okay, now you're kind of back to problems like we saw at the end of last week on Friday. Let's throw this factor back up as an exponent. So it'll be log base 2 of x plus 16 quantity squared minus log base 2 of x equals 6. Now, let's put these logs back together using division since they are separated by subtraction. Right, we're trying to get down to 1 log in the problem, and it looks like it's going to be 1 log equals a number. So it's going to be log base 2 of x plus 16 squared divided by x equals 6. Well, guys, now that we have it down to a log equaling a number, your book will say to rewrite it in exponential form. 2 to that power equals this answer. I like you guys to get into the routine of let's base both sides to a base of 2 to undo this log. And you'll be left with x plus 16 quantity squared over x equals 2 to the 6, I believe is 64. And now again, now you're not solving a logarithmic equation. Now you're solving a proportion. We're going to cross multiply, and it's most likely going to be a quadratic equation. So now I'm going to get x plus 16 quantity squared equals 64x. Well, we're going to have to FOIL this out, guys, because I don't want to square root both sides. I won't be able to square root just an x. So FOIL that out, you get x squared plus 32x plus 256 equals 64x. So like I said, now we have a quadratic equation on our hands. Let's get everything to one side, set equal to 0, and let's cross our fingers that it factors. We don't want to have to use the quadratic formula if we don't have to. So we're going to end up with x squared minus 32x plus 256 equals 0. Well, guys, it actually works out beautifully when you go to factor it. You're looking for two numbers, well, obviously x and x. You're looking for two numbers that multiply to 256 and then add up to negative 32. Guys, 16 times 16, we just did it. It's 256, and they add up to 32. So you need a minus 16 and a minus 16 to make this done. And then when you set each factor equal to 0, you get the same answer twice. So in reality, the answer to this problem is 16. And now check for an extraneous solution. 16, so go back to the original. 16 plus 16 would not be you taking the log of a negative number or 0, and then 16 there would be perfectly fine. So we keep them both. Everybody good? Yes, is it making sense? Okay. All right, I didn't feel comfortable putting these in the homework until I kind of talked about some of these strategies. Maybe you guys would have been fine, but I just feel better talking you through some of them. Everybody at home, are you guys okay?
Oh, are these in Monday?
They're not in Mondays. I took them out, and they're in tonight's homework. So tonight's homework is short. It's only like 6 or 7 questions, but it's these types of problems.
Okay.
Just as I thought the solving was a little bit more difficult, so I kind of kept them separate.
I could say you.
You shouldn't have seen them yet. If they snuck in there, I didn't mean it to.
All right.
Usually the ones from Friday were pretty, I don't want to say simple, but more basic, I should say.
Yeah.
Okay. All right, let's try this one. I'm going to give you guys just a chance to look at this one and see what maybe you're thinking. Oh, I went too high. No, I didn't. It's there. Just think about, what are you trying to do here? What do you know? This one always gets me because I know when I have like a log base 4 of that raised to another log, I'm looking for something to cancel, right? If this base is raised to a log of that kind, but I don't cancel. But there is a property you can use. Anybody have an idea as to what we could maybe rewrite or do? Think about what we know. Right now, it's log base 4 of x raised to log base 4 of x. So it's kind of like the problem, but then it's raised to the exact same problem. Well, guys, at the end of the day, as weird as this problem is, this is an exponent inside of a logarithm. So what does our property say we're allowed to do with exponents inside of a log? We're allowed to drop them down in front as factors. So now it's going to become log base 4 of x times log base 4 of x, and it equals 9. So guys, when you times something by itself twice, that is literally the definition of squaring it. This is log base 4 of x squared, right? I'm timesing this by itself twice. So again, this is not inside the log. This is literally the logarithm itself squared equals 9. And now how do we unsquare things in math? We can square root both sides, and we're going to get log base 4 of just x. Now I've gotten the whole problem down to just one log base 4 of x equals When I take the square root of this, it'll create two versions of that, plus or minus 3. So guys, we end up with two scenarios. Log base 4 of x could equal positive 3, or log base 4 of x could equal negative 3. And now you have two teeny tiny log equations to solve. Either rewrite it in its exponential form using your log loop, 4 to that power equals that answer, or base both sides to a base of 4. And x will equal 4 to the third, which is 64. Over here, same thing, little tiny log equation. Either rewrite it in its exponential form, 4 to that power equals that answer, or base both sides to a base of 4. X equals 4 to the negative 3, so that's 1 over 4 to the third, which is 1 over 64. And there's your second answer. And as long as these answers do not result in you taking the log of a negative number or 0, you got yourself a keeper. So 64 would be 64, not negative, not 0. 1 over 64 is here and there. It's perfect. It's perfectly acceptable. So that was not bad. That was okay, right? Everybody all right? Everybody at home? We're good? All right, I'm going to try to sneak this one in with the last 7 minutes. It's a graphing calculator question. So let me show you a graphing calculator. So if you have it on you, great. If not, just try to listen to the buttons I'm telling you to press. Because again, you guys are a little spoiled in these graphing calculators are programmed to do so much for you, where we might have had to change this into like different bases and all kinds of stuff. You're going to be able to plug it right into your calculator. Guys, I haven't gotten any direction on whether or not I can lend out calculators yet, just because of all the touching. So I apologize if you don't have one on you. Liz, are you okay? Okay, you want to watch mine? Are you all right? Okay. All right, so what we're going to do, when you have a graphing calculator question, guys, you're literally going to treat the left side of the problem and the right side of the problem like two different problems. You're trying to find out, when does this equal that? So you're going to let y1 equal log base 6 of x plus 1 minus log base 5 of x minus 2. Now, if you're on the online homework, they're going to tell you to rewrite your log base 6 and your log base 5 as either base 10 logs or natural logs. Guys, the graphing calculator doesn't make you do that. So why, if you don't have to? And then you're going to let y2 equal 2, and you're going to use the intersect feature. When does this graph and this graph intersect? And that's the solution when they're equal. All right, so really the hardest part is typing them in correctly. So guys, under the math key, if you scroll all the way down, I think it's like the letter A is the option. You have a log base, which will let you type these in. So if I go to Y1, I hit math, I scroll all the way down. After summation, after 0, it's A, log base. And you can literally type in log base 6 of x plus 1. So you can literally, it'll let you type it right in. So again, math.
How do you take log and have your own subset?
Do you have, now see, is this our calculator?
Yes.
If you go to math, see how it says log base? So it's gonna let you put 6 in as the base, right arrow over x plus 1, and then right arrow. Does that make sense?
Right.
And then minus, and then you go back to that math button, get log base again. So 6 of x plus 1 minus, go back to the math, get the log base. What is it, 5 of x minus 2. And then you just hit enter and sort, and then y equals 2, okay? All right. So guys, I'm just looking right away. I know this log has a domain where x has to be greater than -1 to be positive numbers, and x has to be greater than 2. So I'm gonna put my window, the only domain that fits both of these is x is greater than 2. So really you only have to look around 2 and to the right. That's where this graph could exist. So I'm just gonna put my window to be like an x min of 0, because that's close to 2. And then my y min, I'm just gonna put at 0 as well. And then I'll go to my graph. And it's gonna be weird. If you see the graph, it almost looks like it stops, but there's an asymptote at x is 2. But you can definitely see that these graphs intersect. Does everybody see a flat line intersecting with that curve? All you gotta do now is try to find that intersection point. So hit second, trace, and you want that number 5 feature. Second, trace, that button up here, and you want number 5, intersect. And then literally, you wanna move the cursor to where it's near the intersection point. It's gonna be hard to see the cursor. Just keep moving it to the left. If you want, make your Y min lower, and then it'll show you more of the graph, and you'll be kind of out of that like zone where you can't see. But either way, just keep moving it left until the little butterfly, little cursor, kind of appears near that intersection point. Hit enter, and then second curve, it jumps, hit enter, and then it says guess. And you're like, yeah, please do, and hit enter again. And then it says the intersection is roughly when x equals 2.1108. I think they ask you to round to 2 decimal places. Just pay attention to the homework. So 2.11. Now, I did notice on the online homework, they actually accept 2.11, they accepted 2.12, and they accepted 2.10. I just think because, each graphing calculator, maybe the calibration was a little bit different, or your cursor was a little bit more skewed, I don't know. But there's 3 different numbers they took just because rounding is probably gonna be an issue. But like I said, they took 2.11, 2.12, and 2.10, okay? Is everybody okay with that? Everybody at home, you okay? Okay. I did put a warm-up question that I didn't do. I'm gonna do it and then post a picture of it online. It's just a problem from Friday where you kind of condense the logs back to 1 log, but then the problem is it becomes a quadratic formula problem with E in it. And I don't know if you guys were used to seeing that or not, especially the way they ask you to simplify. So I'm gonna put all the work to the warm-up question, and then I'll post it on Google Classroom. So if anybody wants to see that problem worked out, it'll be there, and then you can ask me specifically if you have any questions on, okay? All right, can I, you guys, I almost asked you for a thumbs up. Are you guys okay? All right, at home, can I get a thumbs up? Are we all right? All right, so I gave you a shorter homework assignment. I think it's only 6 or 7 questions on just some of these maybe, more difficult log equations. And then tomorrow, we'll see the exponential equations, which will obviously need logs to solve, okay? All right, I'm gonna double check the attendance one more time, and then you guys are gonna be good to go.